So I'd like to welcome you and thank you all for coming to I think it's the fourth one in our real fiction lecture series, and following on very quickly from Thursday's session with Bruce and Marcus. So we continue our investigation into this very new space. It's very new for designers to be kind of looking at this space. I think not so much, obviously, for the bio artists, and it's great that we've got Jens here to tell us a little bit more about what's been going on in this space for quite a long time now. But for designers, it comes with a whole set of very different issues than we're used to, a very different set of challenges. And in design, I think we learn as designers that design will make the world a better place. This is what we believe that design is about. And in some ways, it's not clear at all what better actually means. What do we mean when we say better? So particularly when we get to the point where engineering and nature come together, or those two things start to bring lots of complexities to them and lots of contradictions. And somehow, as designers, we assume that we'll be able to, make solutions, and somehow that there'll be some technological fix that will kind of, help solve all the problems. And I think what's becoming very clear is that as this space unfolds, that there's, we're still at the very, very early stages of working out what the questions we're actually asking actually are. So tonight we have two speakers who are both familiar with this space of uncertainty, I would say. Both are very, very aware of the kind of ethical dimensions that working in this space immediately arise when you start to manipulate living things and start to design living things. And I hope we'll gain some insights into the methods and strategies, and particularly the attitude that might be required to sort of work in this very complex space of dilemmas. So we'll start with our first speaker, that's Revital Cohen. She started life as a furniture designer, which is quite extraordinary when you look at the work that she's about to show you. And she works with a partner, Tour Van Balen, and they have a practice in London. Tour is actually from industrial design background, and the two of them are doing very extraordinary work in this area. So I'd like to welcome to the stand Revital. Thank you.
Hello, thanks for coming, and thank you, Fiona, for inviting me. So I'm just going to show you a few of our projects and explain our practice through that, I guess. So we put this presentation together. This was one of the first ones that we did, kind of both of us. And we titled it The Machine Body because it was in a stage where we realized that our work has been revolving around this subject of either looking at the body as machine or looking at machines as parts of the body. And I'm going to start with this project from 2008. It's artificial biological clock. And this project came out of research on the way technology affects biology and vice versa. I mean, we are so completely, our bodies are shaped by technology, whether we realize it or not. And for example, this project was inspired by a lot of articles that were surfacing around that time about women that are not having children on time, women that kind of push the age of conception too far until it's impossible. And one of the reasons for this is, of course, technology, either IVF, that kind of leads us to believe that there is time and that everything can be fixed by science, or things even like the contraceptive pill, which change the hormonal balance and, as such, understanding and behavior. So what we designed here is an object which is a prosthetic, but it's not a prosthetic for an arm or a leg. It's a prosthetic for an instinct, for a kind of biological urge. And as such, we wanted it to be based on information because our instincts are, to an extent, based on information that we get. So this object works on the internet, and it's fed information from a woman's doctor, psychotherapist, and bank manager. So when she is ready to conceive, this object kind of awakens and in a way tries to bring back what technology has taken away by using technology, of course. The next project is called Life Support, and it started from a curiosity on what is a cyborg? What is this mythological creature, half computer, half man? And most importantly, do they exist?
You develop a bit of a love-hate relationship with it as time goes on. You know, it's keeping you alive, but then again, it's keeping you a prisoner as well. It more or less dominates everything about your life, really.
You've got to look after them and say respect them, but there's certain things you've got to do for them.
You feel a bit of a slave to it, really, a lot of the time.
I think it does things to your body, I think, when you get emotional.
I didn't really see this, but there was a bunch of dialysis machines. And I went to a hospital, to a dialysis ward, where people are connected to computers, and just asked them questions about what it means when your body is completely part of a machine, completely dependent on a machine. And it's also interesting because these people only use these machines for a few hours a day, so it's really kind of this transition. And the questions I was asking them were not the questions they are normally asked. I wasn't interested, how does it feel and how is your body? I asked them the question a designer would ask. What do you think about the shape of this thing, the color, the sounds that it makes? And of course, most importantly, are you a cyborg? And that was quite a strong visit, and it left me with many questions. And mostly there was one woman that she was crying while talking to me, and as she cried, the machine went out of balance because somehow the salts in her blood changed, and all the nurses came and said, "Oh, stop crying, you're ruining the treatment." So I was left thinking, how come if you lose your eyesight, you get this fantastic Labrador, but if your kidney fails, you're connected to a horrible computer that doesn't even let you cry? There is a man who's connected to a sheep. So we designed a dialysis machine based on a transgenic lamb, as you can see. So this was inspired by a research that I found about scientists making sheep and cows to have human blood. And of course this was kind of invented, although I never found the people who did it. No one accepted that it was them. It was meant to be a solution for lack of blood for transfusions. So what we were saying is, how about instead of killing this animal and taking the blood, we keep it alive as a life support machine. So here, a person with kidney failure would give a blood sample to a lab. They will then make him a transgenic sheep that has their blood. And during the day, this sheep is a pet, and at night it becomes a therapy. So it will work the same way, work the same way a dialysis machine works, pumps, get the blood out of the body, filters externally, but instead of mechanically through an animal, and then pumped back into the body clean. And this is our second life support machine. This is a mechanical ventilator based on a retired greyhound. Now, in this case, the harness, which is the mechanical part, is completely external. The animal is unharmed. And the reason we chose to use a greyhound started from this photo from Google of a woman who clearly hated her oxygen tank so much that she tried to dress it up as a dog. And we were thinking which dog would be the best ventilator machine. So first we started looking at greyhounds just because biologically they have the biggest lungs of all dogs. But the more we researched it and we went and spent time in a greyhound breeding farm outside of London, we kind of learned the story, the life of this animal, and it made it even more suitable. Because greyhounds are a complete product. There's about 20,000 of them bred every year, and they have like 2 to 5 years career in the racing tracks, and then they get killed. So we said, how about this material, these dogs that people are just kind of making, how about instead of that being thrown away, these dogs are retrained and become a partner and a mechanical organ. And the greyhound is also really suitable because after years of racing, they have very severe separation anxiety, so they want to be next to somebody all the time. And the treadmill with a little rabbit was just kind of an interface. If your machine is an animal, where is the on-off button? Where is kind of the switch that you use when you want to make it stronger? And whenever the dog breathes, he pushes air into this bellows that then pushes air into the patient's lung. And while this is just a prototype, of course, it was completely researched and engineered as if it was about to be made. So everything is completely calculated. And of course, this project was very much about the ethics of biological products as we see them, the ethics of our use of animals, of the industry of animals, and the way people got quite upset by seeing these machines while they were not feeling the same for the same lamb being eaten or for this dog being a product of entertainment of the gambling industry. That was a very interesting part of it for us. This project started from a brief about farming and my interest in farming of electricity. Sorry. Okay. And we were curious about how come people try to harvest electricity from nature, whether from the sun or from wind, and mostly in this creature. This is an electric eel. It can make electricity in its stomach. So we thought it was really amazing that there is an animal that can make electricity through its body. And we said, how come people can't do that? What if we could? And amazingly, we found out that we were not the only people thinking that. We found these scientists in Yale University. And they were making artificial cells to behave like an eel's cell. So to behave like these electrocytes, which are cells that produce electricity. And we emailed them and said, could we use your invention? How many cells would you need to make an electric organ for people? And they were quite surprised because they're inventing it as a kind of a medical technology. They imagine a couple of cells being attached to perhaps a pacemaker. But they said, yeah, sure. And they helped us with all the calculations. So we designed our electric organ for people. So this was all part of a scenario of life in 2050, where we were saying people will be even more dependent on electricity than they are now. But how about instead of using the environment to harvest it, they have to use their own body? So one of the main questions when designing an organ is where does it fit in the body? The human body has there's space for everything, every organ has its own place. But then we thought about the appendix, which is kind of famous for being useless. And we thought how poetic that would be to take out this organ that we no longer need and replace it with an organ that we will need. And perhaps this is kind of us evolving into a different species in our own making. And this new species needs electricity more than they need, for example, social contact. This was very, very much inspired by the hikikomori epidemic in Japan, where young people just never leave their room anymore because they run their whole lives through their laptop. They buy their groceries online, they work online, all of their relationships, social relationships are just online, and they just completely stopped leaving the house. And I think the most interesting thing in that for us was that in a way then the human becomes more like the eel in behavior, because humans are meant to be social animals, we're meant to live in a pack. But with those new devices and new technologies, we've changed our behavior. We're now kind of solitary animals. And maybe as such, we should also change our bodies to fit this new kind of evolution. So yeah, to make the cells work, you need to eat a lot of sugar. You can't see it very well, so I'll keep going. Now this project is also from 2011.
Get ready. Go.
So we were looking at both synthetic biology and pigeon fanciers in the aim of designing a bacteria that will make a pigeon shit soap. So this is a bacteria. In the middle of it is the DNA. And through synthetic biology, which I'm sure you've all heard much about and will in the coming weeks, DNA can be rewritten. So we worked with James Chappell, who's a scientist in Imperial College London, and designed a DNA code to make this bacteria. So there's something very frustrating about designing something as tiny as bacteria. But in a way we see it as not just a bacteria, but almost a proposal for a redesign of the city. Because the bacteria sits in the pigeon and the pigeon sits in the city. And it's all just this one big organism that once you redesign the bacteria, you change it completely.
Hopefully they'll produce the best, but don't always work like that. If crappiest beer you got, someone's produced the best racing beers. It's great.
And this is the registry of standard biological parts, very big part of synthetic biology where everything is written. And this is our biobrick, which is the first biobrick ever to have been added to this registry for the purposes of art and not science, which was very important to us. So the bacteria changes the lipase and pH levels in the gut of the pigeon and then makes its shit turn into soap. And this is the DNA code for making this happen. And the pigeon fanciers were quite an interesting sort of part in this project because on the one hand they kind of brought it down to reality and outside of the laboratory, which is a very kind of hidden mystery place. And also because they had this unbelievable knowledge about pigeons that nobody has. So we designed a couple of objects to accompany this work and to kind of show perhaps the potential of this bacteria because legally we could never take it out of the lab. So this object suggests that pigeons become a welcome part of the architecture. Even today I saw in Vienna some pigeon nets and they just ruin everything. This kind of fear of pigeons, the disgust of pigeons has ruined our cities. Everywhere is covered in spikes, in nets, just so they don't come and poo. But what if that was welcome? What if pigeons were welcome in our cities? What if we wanted them to come to our windows and be part of the architecture? So here you can have the pigeon house on your windows and feed them this bacteria and direct them in different directions. And the second object is one to put on the top of a parked car. so the pigeons can stay there, be fed the bacteria, and then defecate on the window and therefore clean it. And why pigeons? Well, pigeons actually are really interesting conceptually because they had such a controlled evolution. In this photo, there are, what's his name? Richard Dawkins is holding Charles Darwin's pigeon. Charles Darwin was actually a pigeon fancier because he really followed their evolution as part of his theory. And one of the other questions that was really interesting for us in developing this work was, is this interfering with nature? And if so, then what is nature? Is a pigeon natural? Because we would say a pigeon is a product, and it was designed just a bit slower. So how about we continue designing it, but perhaps from the inside out? Now, in this project, we continued our interest in life support machines. And we made this installation, which is made of all the existing life support machines, all the ones that are organ replacement technologies. And we connected them to each other in an attempt to create a semi-biological creature. So there's a ventilator, just here in the corner, a heart-lung machine, a dialysis machine, a baby incubator, a cell saver, and maybe that's it. And 2 circuits run through this contraption. One is water, and the other one is air. So for us, these machines were absolutely fascinating because they're an example of how medicine, and indeed also industrial design, reflect the way we perceive our body. So this is the circuit of this kind of mechanical anatomy and how the fluids go and get filtered and then kind of dirtied up again. And we thought it was just so interesting the way we like to pretend that our bodies aren't mechanical, that we don't want to think about the kind of more disgusting things. Because these machines are so Western, they speak of Western medicine and Western perception of the body. They'd never be designed in China, for example. But also the fact that all these things that very comfortably fit in our torso, in their mechanical form, fill up a room. It just gets harder. Now I'm going to show you a little bit of a project in progress. So this is the research stage, and we hope to complete it by 2014. So as you have probably gathered, we are really interested in the idea of designer animals, and animals as a design product. In a way, this is kind of the ultimate biological design. And we got really curious about this particular one. This is called a ranchu, and it's a Japanese goldfish. And these fish were designed in the Edo period, that's 1600s, and they were designed to look like a mythological lion, which is quite interesting. And they are still cultivated, they are sold for a lot of money, and it's a hobby of kind of middle-aged retired men, in a way very similar to the pigeon fanciers. So we went to Japan and started following the path of these goldfish. So this is the national ranchu competition. So that is the most important thing in ranchu breeding, that it goes as far away from the carp as possible. So in a way, this fish wants to go back to its kind of ancestors, and these men are keeping it from them. So they're almost kind of fighting against nature. And this fish is very well connected to the practice of bonsai, and is very much two sides of the same thing.
Tatsugashira. それはドラゴンのような竜ですね。竜のようなtatsugashira。あとは獅子頭。大きくはその2つで、あとは
尾っぽがこういうふうに開いてると、尾の先をこういうふうに垂らして、要するに裾、洋服の裾がありますよね。それをひらひらさせながら、着物をひらひらさせるような感じで軽やかに泳ぐさ。
So we were really interested in how these men approach their fish, and what is their kind of design criteria. What's their inspiration? What's behind a particular rancho? And this sequence is my favorite because it really shows how these fish are products. Off they go. So now, final project is the one we have just finished, and in a way, it's just almost finished. That's why we call it a preview. It's not even on our website yet, but hopefully next week. So it started from this quote. A laborer over the course of an 8-hour day can sustain an average output of about 75 watts. So once again, kind of thinking about the body as a power generator, but also just applying these, this is from mechanical engineering book, just applying all these industrial ideas to the body and to people. So we went to China and we designed and produced a product. I really hope you can see this. So this is our product, and its only function is to choreograph a dance on the assembly line. When I say dance, I mean it in a very kind of open way. It is about controlling the body to perform certain actions that are all for kind of the sake of making this thing, questioning who is the subject and who is the object in the process. We were very interested in these sort of movements of mass manufacturing and what happens when you ask a person to behave like a machine. What happens when you have to repeat the same movement again and again and again, every day, all day long. And there are many studies that I'm going to show in a sec since the beginning of the century about the most efficient way of working in a factory, and really calculating the body's movement to be as mechanical as possible, as efficient as possible. And one of the things that for us were most interesting in that was that these researches were done both in the United States but also in Russia, from completely the opposite sides of the political spectrum back then. Because in the United States they wanted to make the workers more efficient, while in Russia they were kind of worried with workers' rights and in a communist society. And in a way China is kind of the exact clash of these two political powers. And what does it mean for all these people that make our products? Everything that we have almost, and we never see them. So we wanted to make something where it exists there for them. Once we finish this film, these objects have no more function. They were just kind of the artifacts making this thing happen. So we were working with a choreographer for a long time, kind of studying movements of production and testing. Testing is a really big part of manufacturing, of course, and kind of reinterpreting them and designing this object that makes these movements come together. So it was really interesting to kind of tap back into maybe perhaps Tuur's old skills as an industrial designer for the purposes of this task. And we really designed this for production, which was incredibly difficult, but also really challenging and very interesting, of course. So this is a little bit of the object. And we wanted it to somehow reference these old 1920s images of the studies of time and motion and kind of workers' movements. And I think I'm going to end it here. Thank you.
Thank you, Revital. So our next speaker is Jens Hauser, who I think must be one of the most experienced and knowledgeable curators in this whole field of bioarts, who are really, really delighted to have here. And I remember back in when Tony and I first became interested in biotechnology, we knew absolutely nothing about it, and we heard, this was in 2003 or 4, and we heard about this exhibition down in Nantes in the south of France, and we just jumped on a train and arrived in this place, and it's our first kind of experience of seeing any kind of bioart work, and we were lucky to be there at the day when they had a symposium and got to hear Joe Davis and Oren Katz, and for an introduction to biotechnology, I think we were completely sort of like wowed by the whole thing, that this whole sort of area of art has existed. So I'm absolutely delighted to invite you up on the stage. So thank you, Jens.
Well, thanks, Fiona, for having me here today, and it was really a pleasure to have you in Nantes in 2003 as well, because we were wondering who were these people sitting, discussing, and raising all these design questions within the context of art. And we're wondering why you have been insisting so much in 2003 to actually consider that there is a kind of design factor in these new artistic practices, and in how far this would be overlapping with your own practice of fiction design, critical design, and so on that you were proposing at the RCA already at this time. And later on, and I'm quite happy also that kind of lucky overlapping existed later when Oren Katz and myself initiated a kind of biotech art workshop in Stavanger within the Capital of Culture program in Norway. And that a lot of your students were able to participate, and for the first time probably in the actual practice got their hands wet and dirty. And so the question of fiction and design and doing the actual thing, imagining what could be real, this is something I think which came out strongly in Revital's presentation, because everybody's probably aware of the fact that you don't really know where the actual realness stops and the fiction starts, and it's intermingled in a certain way, and there's a lot of things that have been done for real and other imagined. And I think this is interesting, especially when it comes to art dealing with biotechnologies today, because a lot of projects already are realized, but they are sounding as fiction. And just as an anecdote to start with, we had a kind of think tank in Los Angeles in 2005, organized by Laurie Andrews. And we had also Michael Crichton in our think tank, among Bill Viola and among Natalie Jeremienko, other artists and science fiction writers. And I was really intrigued by the fact that Michael Crichton, not only the author of Jurassic Park, but also the one who was supposed to present the ideas of this think tank then to the American Congress in order to see whether bioart, let's call it so, would have the potential to help the American policy to figure out how to do the bioethics laws. And Michael was always only sitting down in the background and just pinning down, never saying a word. And when I read his book Next, his novel, I understood why. Because, in fact, he took the existing art that was made for real as a departure for his own science fiction. So the art was a little bit ahead of the science fiction that Michael Crichton was then able to write out of it. Okay, I don't know how to blow this up. Maybe you can help me and give a... Yes. Thank you. So for me, the title of this very series that you have organized here, Real Fiction, fruitfully denotes in a certain way a series of challenges and misunderstandings in the realm of today's cultural practices based on and related to the interdisciplinary research field of synthetic biology, in its appropriation in art, as well as in recent trends of so-called biohacking or do-it-yourself biology, as allegedly critical and popular subculture. And the questions that we may ask are these associated promises of synthetic biology still real fiction, or has fiction become real, including for cultural practitioners? And has art moved from fictitious representations to manipulating real biological presence because fiction alone does not move us anymore? Or is the field of synthetic biology itself really a trendy fiction in order to generate attention and funds from political agencies keen on catching up with the specters of convergent technologies that have to pay out somewhere? And then, can art, design, or even hacking practices still be really distinguished today, or do they now create resembling narratives in the light of mainstream standardization, modularization, industrialization of living systems that engineer talk does not call beings or organisms anymore? So with the title here, Art Between Synthetic Biology and Biohacking, I will try to inquire which are then the adequate media, art media, design materials and strategies today when the now trendy discipline of synthetic biology aims at designing living organisms on systems from scratch, when do-it-yourself biology seems to become the next pop culture, and when art itself is increasingly linked to knowledge production within what I call the epistemological turn, by which I mean that artists not simply translate what we know, but increasingly how we know what we know. And of course, the creation of lifelike appearances is an ever-recurring feature in art history, and the desire of vivification has surrounded its artifacts. So since the earliest anthropomorphic statues, myths of vivification have surrounded these artifacts made by the artist's hand, and also the animation of malleable matter stands in a long pictorial tradition. And from this 19th century on, the biological metaphor is continued in the discussion of the artwork itself as an organism. You have this book by Willem Wetzold, no? Artwork as an organism, for example, from the beginning of the 20th century. So by means of form, material, and process, a touch of aliveness or liveness is staged, ideally favoring an emphatic mindset to bolster reception and then also aiming to involve the viewer more or less visually. And on the other hand, coming to the keyword of synthesis, art always has involved synthesis, uniting disparate elements, putting them into a collage to create new works, new metaphors, sensory experiments, aesthetic genres. But however, this is also inherent to create to a curiosity that we find across the more recent art history for finding ever new ways by creating with newly available expressive media, and biology and biotechnology is one of them. So art has imagined, represented, mimicked, simulated, and quite recently manipulated, and maybe soon invented living beings and systems for real. So contemporary artists who employ lab methods and biotech seem to be literally particularly close to life. And after painting, sculpture, the automata, etc. from the 18th century, art in the 20th century has employed dry informatics and robotics to stage aliveness, as well as since shortly wet cell and molecular biology. And the use, on the one hand, the use of hard and software would imply what I will call the animation of the technological. And on the other side, the use of wetware entails the technologization of the animated. So now in this emergent discipline of synthetic biology, we can say that the animation of the technological and the technologization of the animated converged. And as a research field that applies engineering principles to biology, it makes soft, hard, and wetware converge and consequently is seducing as a toolkit or subject for artists or other cultural practitioners. So this shift is, on the other hand, paralleled by the democratization of lab tools and their appropriations by artists, tinkerers, or tactical media activists that apply critical potential of open source culture from the digital age of media art to so-called biohacking. And we have some images there that are not really from a biohacking lab, but actually from one of the first workshops in London in 2004, 2005, when the Arts Catalyst, an arts and science agency based in London, was for the first time really making an open call, and around 100 artists wanted to learn how to make a hamster, from a hamster cage and a vacuum cleaner, a sterile hood for $10, how to learn basic tissue engineering, how to run gel electrophoresis, and how to make a transgenic organism in 1 week. But which are then the adequate media to represent biological systems, and how do artistic strategies correspond to this epistemological context of their time? So the recent shift of artistic interest, going from first artificial life, this was with the 80s and 90s, related to software-driven strategies toward wetware biomedia, can also be apprehended as a phenomenon of rematerialization. And this implies today the very material use of molecular biology or tissue engineering, and seems to accumulate in the trendy discipline of synthetic biology. So instead of software-based programmed behavioral and evolutionary features, such aesthetic objects increasingly stage and emphasize the very authenticity and materiality of their biological subjects, objects, processes, or systems. So how can this now translate into art? And Revital also mentioned already this example that I find very interesting, and probably one of the most interesting, and therefore it's maybe interesting also to see where the fiction begins and where the reality stops, because this is in fact a program or a process that has been going quite far, as it accounts for its material reality. And so you already presented this work, Pigeon d'Or, which coincides here with Revital's presence on this panel this evening, as you and Tour van Baalen have joined your practices quite recently. And it's also, in addition, quite situated for discussion here as some of you have maybe seen this piece or one of its manifestations here in Vienna at the Natural History Museum as part of the exhibition Synthetic, which I had the opportunity to create here exactly 2 years ago. So Pigeon d'Or programs, and let's keep in mind that we are dealing with metaphors here, programs real organisms and materializes consequences of an imaginary future in which we would design living entities entirely according to humans' needs. So the project is that Tour von Balen and Revital have been attempting at making pigeons defecate soap by modifying the metabolism of bacteria for real in their gut, employing so-called biobricks, which are standard genetic units to implement new functions. One of the functions being that this bacteria would lower the pH level, and the other one would make the bacteria express lipase, which is a grease-digesting enzyme. So to obtain a kind of glycerine-like, as I understand, substance, which is close to biological soap. So these natural animals then commonly considered as flying rats are equipped with new functionalities and turned into swarming urban disinfection machines. So both on the macro scale, Pigeon d'Or addresses the ethical, political, environmental and safety-related consequences of synthetic biology. And the artists also have created these two designs objects that Revital has already mentioned. This is this pigeonry to feed the pigeons potentially with food containing the designed bacteria, and the other one, this interface for a parked automobile allowing pigeons to land and defecate soap on the windscreen. So, will we suddenly care for the manipulated pigeons' health while usually trying to poison them without remorse, right? I hear the audience sing Georg Kreisler's Tauben vergiften im Park, no? In my imaginary ear right now. And will we treat pigeons differently once they become useful for cleaning our cars? And is it dangerous to release products of synthetic biology into the environment? So, of course, the design of these two pseudo-functional objects is in a certain way a kind of parody. And the design of these artifacts ironically echoes the ingenious talk, the design of the genetic circuits, not of life, but of circuits, of modules, of chassis and standardized parts. This is the installation that was done at the Natural History Museum within the exhibition of Synthetic in 2011. But often there seems to be less irony and more fascination involved when artists, designers and tinkerers hook up with biological students to create and appropriate biobricks, these standardized DNA-based biological circuits, mainly in order to implement new functions into model organisms such as E. coli bacteria or other, and to contextualize and aestheticize them. So these standardized genetic building blocks collected since 2003 in the Registry of Standard Biological Parts by the MIT are almost prone to humorous and subversive design projects, and known examples are for the Achromite project by Daisy Ginsberg and James King, where enzymonic bacteria secrete colored pigments as potentially useful bioindicators, or another example, the Living Mirror by the group C-Lab, also London-based, which can represent photographed portrait images of faces in its biodisplay that is combining magnetic bacteria in a liquid media and electronics. What is striking is that the now popular events, such as the internationally genetically engineered machine competition, in short iGEM, advertises synthetic biology as an open source concept, a concept borrowed from computer and the internet culture. And they aim at emphasizing the collaborative culture of shared programming as the opposite of proprietary soft and wetware owned by big corporations. So, however, we may assume that even MIT is not devoid of commercial interest, And my claim is that it still needs to be carefully analyzed whether the cool dressing up of synthetic biology as open source is not a clever way to de-dramatize a technology that critical observers have called extreme genetic engineering. And in the case of iGEM competition, the ambiguity between institutionally promoted featured technologies, collaborative community practices stemming from digital culture, and the image of the friendly hacker and benign tinkering seem to voluntarily be entertained. So we may be careful about what this means. So, both with regards to the history of art, popular culture, and science, it needs to be analyzed what lurks behind the supposed opposition between the happy hacker in his DIY lab versus the evil and narrow-thinking engineer on the other side. And biohacking evokes, of course, a subculture and anti-institutionalism, and as a growing trend of non-institutional science and alternative technology development, biohacking usually involves soft, hard, and wetware, but predominantly also at-home and field gene sequencing. So I propose to question more deeply whether the analogy with the movement of computer hacking since the 60s is even appropriate. So the notion of hacking in art practices with biomedia has also entered very late only the discourse. Here we are in 2005. I think the Makers magazine emphasizing for the first time the term biohacking was in 2006. I can be wrong. And we also need to remember that in the beginning of these practices with biomedia that artists have been carrying out since the 80s already, the incredible resistance which established media art curators and artists with a background in digital media, in A-Life or in biorobotics, have been fighting such wet biology-based practice for many years as if they have been fearing about their own alleged status of the legitimate avant-garde. So therefore it is worth insisting on the fact that numerous artists today have been sharing their experience and tools already before, totally independently from the media art scene, by running art and biotechnology workshops, such as the internationally proposed by the Perth-based group Symbiotica since 2004. So there is a need to examine the current absorbance of wetware-related art by cultural practices stemming from the digital arts, and which initially have had very little interest in the rematerialization of biological systems as cultural practice. So biohacking also as a cool brand, and despite its great interest for democratization, to me is not devoid of the suspicion that it represents an attempt to integrate these emerging biopractices within the tradition of communication-based digital media art. And I'm just coming back from Copenhagen, being surprised that even there is an institution programming institutional critique in a certain way, because the medical museum, which belongs to the health faculty of the University of Copenhagen, has already their own biohacking display and workshop. So it's not always happening in the garage. So there's a huge kind of capacity of branding this as a new field as well. Just coming back to this historical antagonism, which I find interesting, because early biologically inspired art, such as A-Life art or biorobotics, has been often based on influential definitions, such as articulated in Christopher Langton's much-quoted Santa Fe Manifesto from 1987. According to Christopher Langton, whose affirmations have been taken extremely literally by artists for many years and often have only read this text, I quote, "Artificial life is a studio of man-made system that exhibits behaviorist characteristic of natural living systems. It complements the traditional biological science concerned with the analysis of living organisms by attempting to synthesize lifelike behaviors within computers and other artificial media." And further, since it is possible to abstract the logical form of a machine from its physical hardware, it is natural, without any joke, it's natural to ask whether it is possible to abstract the logical form of an organism from its biochemical wetware. Artificial life should therefore be extending the empirical foundation upon which biology is based beyond the carbon-based life that has evolved on Earth, by therefore locating life as we know it within the larger picture of life as it could be. Ironically, Langton seems to be so allergic to real biology, he seems to be so allergic to carbon, that he even misspells the word carbon on the first page of his manifesto and amputates its R as if he unconsciously wanted to annihilate the very organizing function of the carbon atom as such, while bluntly wishing to get rid of incubators, culture dishes, microscopes, electrophoretic grills, pipettes, centrifuges, and other, quote, assorted web lab paraphernalia. Within the media arts since the 80s, Langton's text has been very influential. The text has become the foundation for a battle between what I will now call the carbophobics and the carbophiles, or even carbofetishists, when it later came to claim the theoretical base for the murky definition of so-called bioart. So just fastly, let's compare these two antagonistic positions. First, the carbophobic artist, the Portuguese Leonel Moura, himself involved in the programming of autonomous painting robots and the simulation of swarming behaviors, affirms that bioart is a new kind of biologically inspired art that campaigns for the emergence of new, artificial, dynamic, and self-sustainable nature. The main point is to generate life as artistic expression, but not life as it is, but life as it could be. And this new kind of art departs radically from the sad idea of using human and animal bodies transformed in artworks, as well as from the practice of using organic materials and the pieces and installations that have plagued 20th century museums and art galleries. On the opposite, a carbophile artist, Eduardo Katz, who introduced the term transgenic art in 1998 after his own previous career in robotic and biotelematic work, claims that bioart is a new direction in contemporary art that manipulates the processes of life, and bioart applauds always the following approaches: the coaching of biomaterials into specific inert shapes or behaviors, the unusual and subversive use of biotech tools and processes, the intervention or transformation of living organisms from a single cell to a mammal, and it is this organic sense that bioart uses the properties of life in its materials, changes organisms within their own species, or invents life with new characteristics. So we can clearly understand the visual animosity between both tendencies of carbophobics and carbophiles, the first accusing the latter of anachronistic materialism and the lack of complexity, and the latter blaming the first for naive digicentrism, inadequate media, and the blind belief in programmable code-based processes beyond the particular materials. So generally speaking, at the risk of exaggerated dualism, of course, the carbophobics propose the animation of the technological, and the carbophiles suggest the technologization of the animated. It comes at no surprise that then the carbophobic artists engage in robots that express lifelike behavior, visualize computer simulations of evolutionary processes, or ecological systems and populations often use so-called genetic algorithms. And on the other hand, carbophile artists would use and material touch-up in transgenics, the synthesis of DNA sequences, cell and tissue engineering, development biology, self-experimentation, or the recontextualization of model organisms from the lab. So we see a recent shift of artistic interest in artificial life related to software-driven strategies and their representation toward the presence of wetware biomedia that can be apprehended as this, what I call the larger phenomenon of rematerialization, from which synthetic biology is also a part of. Now, let's just come back very fastly to this notion of biohacking as a declared extrapolation of the computer hacking spirit. According to the Oxford Dictionary, an act of hacking is a piece of computer code that performs some function, especially an unofficially alternative or addition to a commercial program, freeware or shareware hacks. Transposed to biology, and knowing that, of course, there is an open hardware movement happening in parallel side by side as well, doesn't mainly code-based thinking, I ask, such as totally dominant in the BioBrick and iGEM approaches, programming genetic circuits, calling them like this, does this not lead to a genetics-centered and fetishizing view? Probably Markus Schmidt has given this overview, and I take these categories from him, but it's useful to recall that in this new techno-scientific field that is called synthetic biology, many different chapters coexist, and very often artists, tinkerers only focus on some of them. So Markus has listed DNA synthesis, which is that genetic information is chemically produced and transplanted into foreign cells. Then DNA-based biological circuits, biobricks if you want. Then the research on minimal organisms, which are biological units reduced to the minimal functions that are just necessary for their survival, chassis. Or other kind of chassis would be protocells that would be bottom-up made protocells that are primitive cellular life forms that can be produced out of lifeless chemical substances. And the last field that Markus Schmidt has called xenobiology, which are functional biological systems not yet existent in nature, but also not interacted or supposed to interact with them. Now, an influent article by Antoine Donchamp and Victor De Lorenzo, the authors have asked whether synthetic biology only leads to new words, continuing genetic engineering that biologists have been carrying out since the 1970s, or really to new worlds. And they criticize this US-American focus on mainly being gene-centric and call for a specific European perspective beyond biobricks that also would combine so different fields such as engineering, computing, modeling, molecular biology, evolutionary genomics, traditional biotechnologies, origins of life research, artificial life research, protocell research, protein modeling, and so on and so on. So such a large transdisciplinary approach also prevailed when Markus and I thought of how to create an art exhibition in the light of synthetic biology today. Now, I would just briefly return to another and last epistemological and popular culture-related topic, asking that, generally speaking, where does this positive image of hacking and tinkering as opposed to pure, purposeful engineering of living systems come from? And it's worth to have a look at the reasons for such positive connotations of tinkering when they're employed to address the current phenomena of open source and DIY biology, mixed and enriched with the supposedly ethical conduct of computer hackers when it comes to declare biohacking the latest popular subculture of democratization. In this famous article entitled Evolution and Tinkering from 1977, molecular biologist François Jacob, who developed the operon model together with Jacques Monod, has argued that the evolutionary process of natural selection should not be described by the metaphor of engineering, but by the metaphor of tinkering. So nature, as a molecular tinkery, would, I quote, slowly modify his work, unceasingly retouching it, cutting here, lengthening there, seizing the opportunities to adapt it progressively to its new use. Unlike engineers, tinkerers who tackle the same problem are likely to end up with different solutions. The tinkerer gives his materials unexpected functions to produce a new object. From an old bicycle wheel, he makes a roulette, and from a broken chair, the cabinet of a radio. So why not grow a radio? And here we are back to some of the examples of the exhibition taking place here in Vienna 2 years ago. For example, maybe knowing about this fundamental text. Artist Joe Davis has used variants from a gene from these orange marine puffball sponges to plate electronic circuits. So normally these genes code for the protein silicatin that usually forms this puffball sponge's glass skeleton. And here the gene can extract metals from its environment and plate conductive, although anachronistic, analog radio circuits that should be functioning but have not been functioning up to now. But they could be. There's no reason that they could not, but for right now it's a technical process as well. So what is Davis doing here? I mean, he has been one of those who have been working with biotechnology and transgenics since 1986. And as a forerunner, of course, doesn't give a shit about this recent discipline of synthetic biology. He has been working with this stuff anyway. So by taking the metaphors of synthetic biology literally, he ironically reverses its goal. By tinkering, he applies biological principles to electric engineering instead of vice versa. Another thing that we can, or another project we can think of as tinkering or hacking, if you want. Let's just take the example of artist Paul Van Oos, whose work consists of reverse engineering gel electrophoresis by subversively using analytic laboratory techniques for synthesis. So he is painting with DNA and creates these figurative images by making visible the banding patterns created by gel electrophoresis, the process that is employed in DNA analysis and also called or misnamed genetic fingerprinting. So here Van Oos makes images from a known DNA sample instead of a customary abstract pattern from an unknown DNA sample, and as a result, significant motifs such as IDs or ones, Coppola symbol, even the chicken and the egg, I haven't put it there, but these features emerge, and the artist deconstructs and demonstrates the technical constructedness of the biological identity cards that Mother Nature has supposedly inscribed in our genomes. And even more, Van Oos can also hack the hardware of this this DNA mix in this biohacking bush camp in the Rocky Mountains while running the process of PCR, which is polymerase chain reaction, a process that is a kind of molecular copying machine, of Xeroxing machine, but which asks just for the control of three different temperatures, and he is doing it on an open campfire. So do-it-yourself biology, biohacking, or just an artist having investigated specific skills in gene sequencing and DNA imaging by himself to a degree to create a powerful personal style and ask contemporarily relevant questions. And to do this still through a social, aesthetic, and semiotic system historically known as art, and that seems to be considered by at least a part of the biohacking scene as bourgeois and extremely conservative. So these questions are also relevant when addressing the issues of synthetic biology as a self-declared open source paradise and a sort of tactical hacktivism, a kind of cultural practice which has become the new fanciful trend and ready to claim to be the real legitimate avant-garde in its turn. So, however, maybe François Jacob's similar texts give us a good idea of our cultural desire to see in the technological tinkerer a still reconciling sign of nature. And I hope there is a kind of flash for discussion, and that with Revital's fiction and Fiona's real fiction that we have an interesting exchange. Thank you for your attention.
First questions for Jens. Could you please elaborate a little bit more on that epistemological turn you were talking about in the beginning? So where does it be compared to the epistemological turn with Einstein, or how big is it?
Yeah. Just to say it in very simple terms, I would speak of an epistemological term as an elaboration of an epistemic term, which often comes back into discussion in künstlerische Forschung, artistic research, PhD for artists, and so on. And what is actually the input of the artist as a researcher, and what research, such as in the natural science, can get back from non-linear thinking, for example, when an artist enters the lab. So I think that while in the 60s, 70s, when art and science was popular as an intermingling, you can speak of George Kepes or the EAT, the EAT or whatever initiatives, very often it was about the transposition of knowledge into a kind of form. So it was more about to visualize, to transpose, to know what we know. And I think what I mean by the epistemological turn is to show also how we know what we know. And that you have a kind of democratization approach, for example, in the open lab of Parvanus, not just to stage an image, the final last DNA image, but to be there for 2 months and a half to painstakingly create and forge these DNA images as a cultural practice, and to show you that you are in fact exhibiting the very making of it, and that this kind of tendency has entered a lot of art projects that I know of, and which of course I think that biohacking plays a great role in. Is this
and yes, and do you see a contradiction between art and science then, in the sense of like in science you really have to determine if it's true, a statement, or not true, bring it into a discussion, and then it slowly becomes a fact? In the sense of that maybe in artistic research it's more a subjective way to get the knowledge, maybe by doing, and maybe later think about what you're doing.
Probably when scientists talk among themselves, they enclose and capture all the technical details of the making in this materials and methods section in the end. This is a result, this is a hypothesis, this is a verification, and by the way, this is the materials and the methods. And I think that, for example, having an artist in a lab is very interesting, but how do you do this? How are you sure that the materials and the methods are working? So I think that quite often artists may point to this very short materials and methods section in the end and make this the beginning point of their investigation.
Yes, thank you.
Can I ask a question to Revital with your goldfish project? Can you tell us a little bit what you're going to propose, or what's the next step of that? Because it's absolutely fascinating, really beautiful observations. I'm curious to know what the next step is, and yeah.
To be honest, I'd rather not, because in case we fail, then no harm is done. But also there's something sometimes in kind of telling before it happens that takes the value out of pursuing. But I think we're going to go back to Japan, and we're going to continue working with the goldfish people, and we're going to try and sort of look into their goldfish from our designer perspective.
You're going to design a goldfish, or?
It seems to me that the answer that you've given was kind of implying that in a way the artist is now trying to grab into actually the very conditions of productions of scientists. In a way, this genesis of productive means that the artist is going on could be seen as a kind of as an attempt of trying to understand and to reappropriate, but reappropriation in a means to rechange the very conditions of how scientists think. And this is then for me the question with your last statement, so the statement about aesthetics as a kind of a semiotic social system culturally enclosed in a particular space. So if you could elucidate more about this, well actually this co-transdisciplinary move, if you could actually put it out towards aesthetics.
Well, there was a lot of content in this question already. I think that it appeared to me when I was interviewed by a kind of known science writer, science and art writer, which I'm not going to name, not to blame, but who, to my opinion, asked very awkward and conservative questions while having been himself confronted with a situation in which he has been feeding in some ideas in an art and science project, and then he saw the artist's name on the wall and he was just listed as a collaborator. And he was so upset by the situation that he decided to write a book about what does the scientist please get back, you know. The artists are using all my ideas, you know, without my ideas there's nothing in the artwork, you know, it's just spaghetti, you know. And yeah, so, but he was in a certain way having a kind of Freudian experience, right? So, and he is interviewing everybody right now, claiming that, well, the scientist has to get something back, he has to learn from the artist. And so this interview was around these things. And I said, yes, the scientist is probably getting back something, but he's probably not getting back something equal, you know. He will probably not just have the expectation fulfilled that the artist is coming in, doing nice visualizations and helping by these visualizations or other kind of aesthetic translations, help the scientist to move forward in his thought. But maybe through this impertinent questioning and pointing to this methods and materials section, he will open up the minds of the scientist, which very often has not the luxury as a total, epistemological thinker, but more as a specialist. And my own experience while working in this field since some years is that I'm not a biologist. I have learned about biology, but I'm not at all a biologist. But talking to biologists sometimes can be very frustrating if you leave the specific field of interest and go just beyond. They do not know anything. Nothing, empty, right? It's so frustrating. So the artist may bring something in, but it's not exactly what very often scientists expect. So I think what I wanted to emphasize is this moment, that it's a situation of fruitful misunderstanding.
I'd like to kind of add in here, I think for me the interest from the synthetic biology kind of rhetoric that's around is not so much the, for me it's the idea of breaking down the boundaries within the science community itself that I find the most interesting. The idea that at a very young level, in the Cambridge iGEM team, they put a physicist and a biologist and a chemist, and they make a team of scientists who would never normally speak together, and then we throw in a designer because equally, in that sort of space where the normal science boundaries are starting to break down and different kinds of questions are kind of open up, regardless of the kind of rhetoric or thing. I actually think that those methods and processes of inquiry are changing, and very young people are sort of feeling empowered to ask those questions, and it's not just coming in the silos of education. But for me, that's the most exciting thing about synthetic biology, regardless of whether, the rest of it. It's this access, the changing of those structures. And I think in some ways, Tour would never have gone across to Imperial College to find out, about, changing a DNA, or even think you could possibly do that without those sort of boundaries beginning to break down. So I think that's a kind of positive exciting side of this sort of opening up of space to enable sort of the kind of access. And so a question I would like to put to both of you is more about access, the idea of access to the technology, not just the technology itself, but to the kind of the infrastructure of the rhetoric that's going on also within that space. What can you say a little bit about access to these big science institutes?
Well, I think that's by far the hardest thing. Always to first kind of have them willing to hear you and who you are, and there's a lot of time of persuasion that we are serious, that we are not, that it's not a joke, that we're not going to use them, that it's not going to damage. But also, I think what Fiona just said about the synthetic biology, it's true that the guy that went all the way with us, he was 24. And that made a big difference because he was still really open to anything, and he saw this as fun and as part of developing his interests, and he really felt that he was gaining from it as much as us, and he is credited on this project equally as us, although he doesn't really care. We always mention his name because it wouldn't have happened without him. And I think that's just a really big difference. And perhaps it's not just science, perhaps anyone that's been practicing something for absolutely years, and then someone just kind of comes in out of nowhere, and it can be so foreign, sort of art and design, to some scientists. They have no interest in it. So it's difficult. But I think we also have very different strategies, Tor and I, where he really understands science, and he really, very quickly, they see that he speaks their language, and they open to him. Well, I don't even pretend to speak the language. So I kind of take the back seat on this a little bit.
Well, what you're saying is, I think, very important, that it's much based on the personal contact. And it's not just based on, I have this project, I will Google up exactly the specialist in this area, will ring up to say, you're the best one to do this, and when can you read? No? Maybe not interested at all, you know. And this personal thing is something which you cannot replace by any kind of collaboration on an institutional level, to my experience. And in the very beginning of this work in this field, I had a chat with Hans-Ulrich Obrist, and he had organized this exhibition series called Laboratory, even staging work in the laboratory, which was, well, an attempt to make this happen and integrate scientists in a kind of transdisciplinary approach. And I said, well, wouldn't it be good if we created a kind of art and science agency, something which, you know, have an artist wanting to work with a scientist and just, yeah, hooking them up, you know? And vice versa, you know, an artist or a scientist saying, I'm very good in material science and I would love to work with an artist, and can you search for one? And Hans Ulrich said, well, yeah, you know, it's a great idea, but it will never work because, yeah, once you are really on the institutional levels, you have so much constraints, health and safety issues, and and every project is so different. So creating an infrastructure is probably not the way that can pay out. So, on the other hand, very often I see also that some scientists now approach artists. You know? It's also vice versa. It's not only in this one direction. You know? I'm interested in science and art as an ever-expanding field. Among other practices, goes into the natural science. I think the other way it's happening as well, but it's less known, maybe because also scientists, which originally, to my experience, have been interested in art, are very much interested in formalism and in 19th century art and in beauty. But there are some, and maybe when the artist goes to a science lab and everybody claims, yeah, you have to learn about the science, there should be the other way around too. I mean, if you want to collaborate with an artist, you will have at least a crash course of 20th century art not just to be stuck with a kind of cheesy aesthetics from Bach to Picasso, right? But this way around, it's rarely thought, because we are already so thankful that the doors open to let artists in.
Yeah, I have a question for the 75-watt project. So how do you see, and I think this is a question that concerns all of design, the relation between human interaction and the human experience and design. So here, to see it under the aspect of some kind of, if a human is forced as a filler in all kinds of systems, do you see there is a problem?
Absolutely. I mean, I think our work is not really about kind of declaring something as a problem or the opposite. We don't really have an agenda where we kind of want to promote a specific approach. We just find something very interesting and on the gray area, because yes, it's kind of disturbing what they do, but it's also true. We all kind of do it. So that's these kind of points where something is not really clear. It's bad, but it's good, and that's where we would normally pursue a project. That's where we'd say, okay, this is interesting. But we also see this project a bit as kind of the swan song of production as we know it. If you think of all these technologies and what they sort of promise, assembly lines such as this are not going to exist. This is kind of the end of this particular industrial revolution. It's the end of this kind of chapter of the way we receive products, we make things, who makes them, the way they are transported. So we kind of saw it as a ritual to close that chapter.
Again to the 70. Okay. Yeah, because the whole Fordist system and all this that they did, what we learned from it was that it failed tremendously and that it really didn't work. And that's why right now we're talking about the post-Fordist society and a society of communication and interrelations and so on. And if you say that it's on the gray zone, what is it actually that we can learn positive from it? Because at least what's told in the textbooks and so on is that the whole Fordism and Taylorism, it didn't work. That's what it says.
I mean, we have this crazy network of products. We have like a whole school teaching people to be industrial designers. So it must work to an extent. It works.
But it's rather about the process that they were working in a way that the whole breaking down a activity to a very small pieces of simple things, and then the guy who is in the beginning of the assembly line has no clue what the other guys are doing.
The thing
So
is,
this
it
kind of
really works. We were actually quite amazed by it when we were filming, the way that, because at some stages we had to kind of swap people around, and we tried a bunch of things, and it really works. It's as a process of making, because also every few hours of filming we had to kind of rewind to start again, because we only had 40 objects. And when we each just grabbed an object and started disassembling it, it took so long. And when we just started kind of passing them back and everyone did their part in reverse, it was so fast. So perhaps I agree that we can maybe say it doesn't work in terms of kind of humane treatment of people, but technically to make something very quickly, it really works. So that's kind of the in-between.
Have you ever seen a connection to the performing arts, to Anne Bancroft, for example, or have you seen a connection to the performing arts performances like Anne Bancroft or or the likes of?
Well, we weren't really thinking of it that way. We are designers, and we worked with a choreographer, and I must say that I don't have much knowledge of performance art, so we were more looking at kind of between contemporary dance and just these films of factories that we made in China 2 years ago.
I have a question about the acceptance of animals as products, and for you it seems to be normal that animals are products. And coming from the UK, obviously animals are seen in a very, very different light. Would you comment a little bit more about the difference? Have you noticed in different countries different attitudes to how your work is kind of received?
Yeah, absolutely. I mean, also this kind of view of animal as product, it's something which is really important to us to discuss. It's not necessarily kind of something I would promote, but I also don't want to kind of scream against it and just, because nobody listens when you have just the message. But it feels like this is just the truth and nobody realizes it. And we try to kind of surface that, make it visible, and people can then make their own judgment whether it's good or bad. But we definitely felt that, for example, in China, that was totally fine. Anything goes, no problem at all. When we showed our work, that was, even someone asked me, like, why don't you do it with the animals, machines? But yeah, of course, in Europe, it seems quite different. And it's also, I think, online is something that makes people quite upset. So, but that's good. Upset is a good reaction for us. I think that's what our work does. It's not in shops. It's there to make a reaction, to make people think, to ask questions. So I just think that one is a very strong kind of topic which brings a lot of emotions every time.
Maybe taking the example of animals as well in so-called biotechnological art, or when animals are used for artistic purposes, which is of course felt as being frivolous in most of Western cases of society. Wendell Webb, for example, who had his pig tattoo farm in Beijing for the Year of the Pig for some years, and tattooing these pigs with all kinds of motifs. Let's say Bin Laden is a Jesus on the cross with the 3 little piggies running around, tattooed, and Disney-like style. And these pigs then were sold as well. They were being exhibited. And for example, in Belgium, when the museum wanted to stage them, they had to register, not at the Ministry of Culture, but of Agriculture, officially as a piggery. So the art museum became a piggery, welcoming these tattooed pigs from China. And what Wim told me about this China tattooing farm was that he really had to teach the people to treat pigs humanely, and that he was anesthetizing them while tattooing them, while everybody was really treating them like shit. And then that he was really amazed by the difference in cultures, that people really blamed him to mistreat pigs while making it art objects. Well, he said, no, I saved them because now, and I teach the Chinese people how to treat them humanely. There's a lot of cultural difference when it comes to biotechnological art. This is a whole different chapter, so I'm not elaborating on this, but.
Back to the factory. Maybe I missed it, but were those factory workers or dancers or performers, or who were these people?
They were factory workers.
And you paid them for their time, or what was the setup?
Yeah, we paid them for their time and fed them. And we paid the factory boss, but according to their time.
I have a continuing question. And the object, did you design it in advance, or did it come out of their movements? Or does it have a function that is pre-designed?
The only function is to make this choreography. So we designed it in advance, but we couldn't with them, obviously. So we just did it with dancers, actually, in London, because our choreographer, he's a resident at Royal Opera House, so he has a studio and a group of dancers. So we just brought a lot of things and tried, and we were looking for things that can make very big movement but still collapse into a small object so we can ship it back. So it just came out of all these experiments slowly. But for them, it was a first to kind of.
But with many of the moves, you did have to tell them to pick this up in this way. It wasn't the object that made them, turn around that way. You could have just turned around like you usually would.
Well, everything was kind of based on where it was. Even when they had to get up, it was because some of the parts were up, which was all derived from what factories are like. We started by going to China and just going into factories and filming. And just from that, we showed our choreographer and we said kind of, can you spot things that happen? Because we didn't even realize, for example, how much movement is there by placing, for example, the screw on top, so you have to reach out for it. So everything was kind of based on movements they would do, but of course we also exaggerated it a little bit, because it's a film.
Well, maybe we should finish there and have a drink and actually have a discussion with some beer. So I'd like to thank both of our speakers tonight. Thank you. A round of applause.